Hello everyone, I once again welcome you all to my channel MaxMaths. Before starting today's lesson, I'd like to thank you all for supporting me. Please keep supporting. Thank you so much once again. Let us start today's video. Today we are going to discuss about rational numbers, irrational numbers and real numbers. We have already discussed about these types of numbers. If you don't know what these numbers are, then do check out my first video to understand these types of numbers. Now let's understand what are rational numbers. Rational numbers are the numbers which can be written in the form of p by q, where denominator should not be 0. Rational numbers can be represented by a capital Q. These are some examples of rational numbers. Now the question is, which numbers can be written in the form of p by q? We can write natural numbers in the form of p by q. To understand this, let us take a natural number 5. We can write 5 as 10 by 2. Similarly, we can write whole numbers and integers in the form of p by q. So we can say that all natural numbers, whole numbers and integers are rational numbers. Are there any other numbers that can be written in the form of p by q? Answer to this question is yes. The decimals, terminating decimals and non-terminating repeating decimals can be written in the form of p by q. Now first understand what are decimals. A number which has a decimal point in it is said to be a decimal number. We mainly have two types of decimals. The first one is terminating decimal and the second one is non-terminating decimal. If a decimal has a finite number of digits after the point, then the decimal is said to be a terminating decimal. And if a decimal has infinite number of digits after point, then the decimal is said to be a non-terminating decimal. If a non-terminating decimal has non-repeating digits after point, then the decimal is said to be non-terminating, non-repeating decimal. And if a non-terminating decimal has repeating digits after point, then the decimal is said to be non-terminating repeating decimal. As I said, terminating decimals and non-terminating repeating decimals can be written in the form of p by q. Now let's see how can we write these decimals in the form of p by q. To convert a terminating decimal into a rational number, first count the number of digits after point, and if there are 2 digits after point, then add 2 zeros to the denominator, and if there are 3, add 3 zeros to the denominator. In example 1, there are 2 digits after point. That is why I have added 2 zeros to the denominator, and then I have divided the number with 5. And in example 2, after point there are 3 digits, so I have added 3 zeros to the denominator, and then I have divided the numerator and denominator to get a simple rational number. In example 3, as you can see, after point there is only one digit. That is why I have added only 1 zero to the denominator, and then we can't divide 7 and 10, right? So I have written it as it is. Now let's see how to convert a non-terminating repeating decimal into a rational number. As we know, a non-terminating repeating decimal has repeating digits after point. So first count how many number of digits are repeating after point. In this decimal, you can see the bar is on 3 and 6, which means this 3 and 6 both digits are repeating after point. So to convert this non-terminating repeating decimal into a rational number, we'll follow these steps. In the first step, we'll take this non-terminating repeating decimal as x, and let us say that x is equals to 0.3636 and so on is the first equation. We will now multiply first equation by 100. We are multiplying first equation by 100 because there are 2 repeating digits after point. If there are 3 repeating digits after point, we'll multiply the equation with 1000, and if there is single digit repeating after point, then we'll multiply the equation with 10. When you multiply first equation by 100, you will get 100x is equals to 36.3636 and so on. When you multiply a decimal with 10, 100 or 1000, the point moves forward. We'll learn about this in our upcoming videos. For now, understand this: when you're multiplying first equation with 100, you're getting the second equation. Now subtract first equation from second equation. We'll get 99x is equals to 36, and when you send 99 to the RHS, you'll get x is equals to 36 by 99, which means x is equals to 4 by 11. And hence we can say that this non-terminating repeating decimal is a rational number. At last, we can say that all natural numbers, whole numbers, integers, terminating decimals, and non-terminating repeating decimals are rational numbers. Let's see what are irrational numbers. The numbers which cannot be written in the form of p by q are said to be irrational numbers. And a capital S can be used to represent irrational numbers. Root 2 is an irrational number because we don't have a perfect square root of 2. And the second example here is an irrational number because it's a non-terminating and non-repeating decimal. Real numbers is the set of numbers that includes rational numbers and irrational numbers. And the set of real numbers can be represented by a capital R. Make sure to like, share and subscribe my channel. Thank you.